This is our physics project for Miss Benson's class. In this video, we are going to be showcasing an example of energy transfer as well as calculating the work of our system. The scenario we are depicting in this video is of a toy car going down a straight line on a table, up a ramp and back down.
Hey Nikita, what are you doing there?
Oh yeah, what's up, Zach? I'm just playing around with these cars right here. They have wind back motors in them.
Wow, how do those things work exactly? I've never known what makes them move.
Weren't you listening in class? Miss Benson taught us this, eh?
Was that a lab day? I wasn't listening, I don't think.
Yeah, it was a lab day. I mean, you want me to teach it to you? I mean, physics is fun.
Yeah. Yay!
Alright, Zach, let me first explain to you how energy is transferred from our hand into the car.
Okay.
So basically, here's your hand, and when you pull back on the car, when you pull it back to here, the energy is transferred from your hand into a spring, which is in the motor of the car.
So what makes the car move?
Okay.
And what happens to the energy from that point?
When you release the car, the energy flows out of the motor, out of the spring, and into the wheels, and these wheels propel the car forward.
Okay, so how about in this scenario with the ramp? The car goes up, I notice that it slows down as it's going up the ramp, and then it comes back down. Why is that?
Okay, I'll show you here. So basically, when the car starts out, when we pull it back, it gains kinetic energy. So when it's going up the ramp here, it starts to lose the kinetic energy. Well, not really lose it. It becomes transferred into the gravitational energy, like of the Earth. And then when it's fully out of kinetic energy at the top here, its speed is going to be 0, and all the energy is going to be transferred into the Earth's gravitational field. So this thing isn't going to be moving. After that, gravity lets it fall back to the Earth, and it starts to gain more kinetic energy.
Alright, so Nikita, that was a good explanation of what Miss Benson was talking about in class. Can we do the math and the calculations for the situation?
Sure, let's go ahead.
So Nikita, how do we measure exactly how much energy in the unit of joules is stored into that motor?
Okay, so basically, Zach, there's an equation we can use for that. And what we need is the force that I pull back on in newtons, which I'd say would be about 20 newtons. And we're going to need the displacement of how far I'm going to move the car, which would be about 10 centimeters right there. And which is going to be multiplied by the cosine of the angle of the force. So here it's going to be 0 degrees because my hand is pushing this way.
Thanks, Nikita, for the explanation. It was thorough and well done.
No problem.
Appreciate
I got
it.
you.
Flick it for me. Flick it for me, fam.
No.
Give her a flick right there.
No.
Come on, man. Flick it for me, bro. Bro. Oh, yeah.